freezing point and one is your boiling point and the ignition temperature, right? So ignition is basically heating. So for example, if there is a flame, so of course it will reach to the this, what is this, ignition temperature, right? But when there is a water, right? So water is what? Water is basically cool now. So what it do? It is basically opposite of heat, right? So at
Yes.
that moment, it will not reach to its ignition temperature. But in case, in presence of fuel, right, it will reach. But in case of water, it will not reach.
Okay, ma'am.
Yeah.
Ma'am, you only teaching, ma'am. This is just too confusing.
That's why I asked you to read it. Okay, just read it till here, substance, then I'll explain you everything. Today we are not going to make notes. We are going to only understand the NCRT. From Saturday onwards, we'll be making notes. Okay,
Okay, ma'am.
done till here. Can you list some more
Yes,
influence?
ma'am.
Okay, let's just complete it and then I'll just start.
Alcohol, petrol, gas, silver. Yes, ma'am. I read it.
Okay, so let's just start.
Ma'am, can you zoom in?
Hmm.
Zoom.
So very first is it fine now?
Yep. Yes, ma'am.
Okay, so let's just start with the chapter. So what is your chapter? Your chapter is combustion and flame. So combustion is basically the process where, where heat is being produced, right? And flame is basically the flame, the burning one. Now we use different kind of fuels for various purposes at home, in industry, and for running automobiles, right? So you have different types of fuels, right? So whether you use that fuels in your home or in automobiles or in factories and all that. So can you name some fuels? You use petrol, say, like this LPG and all that. These are fuels. Coal, wood.
Diesel, paraffin, ma'am.
Yes, yes. So what fuels are used for running automobiles? Your list will contain fuels like cow dung, wood, coal, charcoal, petrol, diesel, and CNG. CNG is basically, it is used in vehicles,
Compressed
right?
natural gas.
Yes. So you are familiar with the burning of candle. What is the difference between burning of a candle and burning of a fuel like coal? So see, burning is all a process, right? Candle is also burning and plus your fuel is also burning, right? So what is the difference? So you can see when candle is burning, it is not producing any energy, right? And it is not helping an object to move or to produce anything. But when a coal is being burned, right, it is producing energy which is helping the, for example, I'm using coal for the railways and all that, right? Or for ironing the, the shirts or the clothes. So basically what they are doing over there, they are producing energy which is helping in other activities, right? But for candle, have you seen anything like that, that because of candle you are getting any energy, or you are converting it, or you are running your vehicle, or you are pressing your clothes with the help of candle? Is it?
No, ma'am.
No. So this is the difference between that and the coal and the candle burning. So maybe you were able to guess right. Candles burns with a flame, whereas coal does not. And remember one thing: when you can see candle is burning and slowly it is being melted. Right? It is burning with a flame. Flame you can see. Right? The flame is basically the, you can say, fire. Right? But when a coal is being burned, have you seen fire? No, na. It just only produce smoke or something like that. But over candle you see flame, right? But in coal you don't see any flame, right? So similarly, you will find many other material in burning without flame. So there are lot many material we don't burn with flame. So flame is basically, see, for example, you are burning wood, right? So if you are burning wood, so at that time what is happening? Wood is, you can see the fire over there, right? But similarly, if petrol is being burned means, like, if you are using that petrol for your bike or for your car or anything, it is not, you can see, like, can you see that there is a fire going on, a burning fire? No, right? So
No,
you can
ma'am.
compare. I think there is a list where you can compare the things, right? Where the things which are being burnt with a flame, and there are things which don't burn with flame, right? So now let us study the chemical process of burning and the types of flame produced during this process. So now we'll be understanding the chemical process of burning, how burning takes place and how flame is produced, and what is this process. Clear? Now, next, what is combustion? So this is important, right? So recall the activity of burning a magnesium ribbon performed in class 7. So you remember that magnesium ribbon when you were doing the chemistry part? You remember that? 7th class?
No.
No. Okay, so basically there was a thing like where you are going to burn that ribbon, it becomes like ashes and all that, right? So we learned that magnesium burns to form magnesium oxide. So the magnesium, when you are going to burn that, so it is being converted into magnesium oxide, right? And with that, it produces heat and light, right? So it's like, for example, you are burning a cracker, something like that. When you burn a cracker, you can see it converts into ashes, right? The ashes plus,
Yes, ma'am.
right? And you can see the heat is being produced plus the light is being produced, right? So this is what. So we can perform the similar activity with a piece of charcoal. Hold a piece of pair of tongs and bring it near the flame of candle or the bunsen burner. What do you observe? So you have a charcoal, a piece of charcoal. So you have basically tongs with you. So tongs are basically the piece where like with help. Like tongs, I hope you are aware of it. Like your mom makes chapati, so when we use that tongs, right? So
Yes.
when you will bring that, it will basically first burn and they will also produce heat and light, right? So we find that charcoal burns in air. We know that coal too burns in air, producing carbon dioxide, heat, and light. So this is first thing. Remember one thing: carbon, charcoals, and everything, they burn in air and they produce carbon dioxide, heat, and light. Okay, so CO2, light, and heat. They produce all of these things. Okay, clear?
Yes.
Okay, so now, ma'am, what is combustion? Combustion is basically a chemical process in which substance react with oxygen. See, when you are burning something, of course, oxygen is present in that. Yes, right. That's why you are able to take oxygen. Na? Whether you are in washroom, whether you are in terrace, whether you are in park, whether I'm sitting in my jungle, here also I have oxygen. Everywhere you have oxygen. So if you are burning anything, so that means you are burning that product in presence of oxygen, right? So when a chemical process in which a substance react with oxygen to give off heat is called combustion. So when you are going to burn that, you are going to produce heat, right? So that is combustion. So combustion is not simply just burning the material, right? So combustion is basically the process in which substance react with oxygen to give off heat is called combustion. I hope now it's clear. Combustion, right? So you have to remember these terms like oxygen, heat, and all that, right? And see, for example, you wrote it like that: the chemical process in which substance react with substance burns and they produce heat. That's wrong. Why? Because you missed out the oxygen part. Because oxygen is available everywhere, so you have to make sure that oxygen is being like oxygen is present, and in the presence of oxygen combustion will take place. Or for example, can you please tell me, like, if I just gave you an example where I just told you that I this was a product and I burned that, right? So that process will be known as, if I didn't mention
Combustion.
the no if I didn't mention this presence of oxygen.
Well, of course, no, it can't be combustion.
Yeah, so it is basically simple burning, right?
Yes,
So
ma'am.
combustion, yes. And one more thing,
Ma'am, but
whenever
I didn't
the
understand the difference. I mean, like, you in burning also you need the presence of oxygen has to be there, right?
yes, there has to be, but if you will not mention it, so it is incomplete definition for combustion. Clear?
Oh, okay. Ma'am, you're confused.
See, burning is basically, burning is
Yes,
simply you are
ma'am.
burning something,
Ma'am,
right?
I
So
was
a
pretty
proper
clear.
term.
Ma'am, I was pretty clear. Then you're like, then it's simple burning. Ma'am,
Okay. No, it's basically the same thing, but the only difference is that, like, combustion won't be a complete definition. It will be incomplete until and unless you don't mention heat, as well as if you don't mention this oxygen part. So it is completely a, you can say, incomplete definition, right?
yes, ma'am.
Okay. Now the next thing is the substance that undergoes combustion is said to be combustible. See, not every product can be combustible, right? So the substance, like for example, I'm burning coal. So coal is basically, what is the coal? Coal is combustible, right? Because of coal you can make combustion. You can follow the process of combustion, right?
I mean, so any substance which can be combusted is
Hmm. Hmm. The
com-
see, the substance that undergoes combustion, right? That is known as combustible substance, and they are also known as fuel, right? Why fuel? You already know fuel is basically when you will burn that product you will be getting heat. That is fuel, right?
okay.
So yes, the fuel may be solid, it can be liquid, it can be gas. You already know solid: charcoal, coal; liquid, petrol, diesel; and gaseous, carbon dioxide, all that, right? So sometimes light is also given off during combustion, either as a flame or as a glow. So sometimes whenever heat is being given, okay, that you already know, right? But sometimes light, you can see that there is, the sparkle or something like that, right? So we can also say that during combustion, sometimes light also takes place. Like you can also see, sorry, you can also see that light is being produced, right? And that light is known as flame, or you can say glow. You won't say that, ma'am, look, light is being there. No, you'll say, ma'am, see, it's a flame, right? Flame. Sorry, it's a flame. Flame is being produced, and you will say, ma'am, glow is being produced, like this. Okay.
Oh, okay.
Okay. Now, next thing. See, over here, this part, we find that for combustion, air is necessary. The candles burn freely in the case when air can enter the chimney from below. In case B, when air does not enter the in case when air does not enter the chimney from, the flame flickers and produce smoke. Right. So see, remember one thing. You did notice one thing. I mentioned that I never mentioned that it will produce smoke. Right.
No, mom. No, you didn't.
Yeah. So why I didn't mention it, I'll just explain you later on that why I didn't mention it, that thing. Okay. So over here you can see there are three different cases, right? So ma'am, what are the three different cases? First, see, we find that for combustion air is necessary. You already know this, right? And then the candles burns freely in the case when candle will burn freely when air can enter the chimney from below. Okay, so you can see from there air can enter from everywhere, right? Second case, when air does not enter from chimney from below, the flame flickers and produce smoke, right? So instead of producing heat energy, they'll be producing smoke at that time when air is insufficient. Getting the point? Right, so at that moment
Yes.
only you get smoke. For example, let's just take an example of coal. So whenever you burn coal, so what people do basically for burning the coal, they just produce they just from the with the help of a tube or something, like in rural areas, they they pass oxygen, right? So what they do whenever they are like foo foo foo, as like something like that, they produce smoke with the help of that. So what basically happens that they are producing the things with the help of that only, right? So now when it takes place, when in starting little amount of oxygen is being given to that, so in the starting itself there will be a lot of smoke, right? But once the charcoal or the coal, they get sufficient amount of oxygen, they will burn like normal thing, heat and light will be produced and all that. But in starting, because see, in starting only you cannot give all the a sufficient amount, right? So in starting it's like slowly you will increase the amount of oxygen. So in starting you can see there is basically, you can say, what will be there, the smoke will be there, but after on when the object is getting the sufficient smoke, there will be no oxygen, sorry,
Mom, I
there will
have
be
a
no
question.
smoke. Yes.
Mom, but in the B one, like
Hmm.
why? I mean, after it is after like when you don't when the air is not coming from the downside part,
Hmm.
that means the candle won't burn.
Yeah, a flame
Mom, but
flickers and
I
produce
think,
flame flickers. See, until and unless you don't have oxygen, how you will how will you produce things?
mom, but it's coming from the upward direction, right?
Chimney is basically, chimney is produced in such a way. If chimney is produced in such a way that you will be getting oxygen from within and you will be releasing the smoke from outside, like from upper side, right? It is produced in such a way, right? So it's not like from there also air will be coming. See, if in case air is coming from downwards, also from upward and downward both, so it will be like where the smoke will be going, right? So chimney are produced in such a way that smoke or any produce will be going outside from upside, right? And it will, like the oxygen and everything, they will be coming like from the downward side, from the below side. Clear? Okay. Now,
Understood.
yes, last the flame finally goes off because the air is not available. So lastly, what will happen? See, if that product is not getting a flame, like if that product is not getting oxygen, so it will goes off. Like it will completely, flame will goes off. Like earlier, what was happening? It was flickering, right? Slowly it was flickering. But time will come. See, there can be two situations. One, if you got if that product is getting sufficient oxygen, then it will burn, right? But in case it doesn't get sufficient, then the flickering will be stopped and air, like it will be like somewhere goes off, it will remove, like there will be no at all, no flame, nothing will be there. Clear? Okay. Now, see this one. You might have heard that when the clothes of a person catch fire, the person the person is covered with a blanket to extinguish fire. Can you guess why? I think now you can answer this. Swear. You might have heard that
Ma'am,
when the
because maybe like the I mean, like the coat. I mean, whatever is I mean,
blanket. For example,
blanket.
this is the
I mean,
person. Yeah.
I mean, it's not a good conductor of heat.
Swar. This thing right now only we discussed when your flame will be stopped, when there will be no flame or nothing. Tell me. Okay, tell me. When there will be high flame.
Ma'am, when oxygen is coming from both upwards and downwards.
Okay, and when the flame will flickering.
Ma'am, when what do you mean of flicker?
Flickering means like fadfadana. Have you heard that?
Yes, ma'am.
So that is flickering.
Ma'am,
Flickering is like burning. Like somewhere it is close to, either burning or close to even disappear.
okay. Ma'am, when oxygen is coming from the upwards direction and not from the downwards direction.
So I see. We have three conditions. One, the first condition is basically that when the things are not in control. See, first you are getting sufficient oxygen, right? Sufficient oxygen, so flame will be burning in 100% flame will be there, right? Second situation, you are not getting sufficient oxygen, so flame will be flickering, right? And third situation, when you are not getting oxygen at all, so flame there will be no flame. Clear? So you have to understand the logic of oxygen, right? So over here, you can see the question. You might have heard that when a clothes of a person catch fire, the person the person is covered with a blanket to extinguish fire. So can you guess why? So just tell me. For example, I am sitting here. You are sitting here. Air is being surrounded to you. Yes.
Okay.
So right now, if you will catch, if some, for example, there's a human being. He is sitting like you. Okay, like me. So right now you can see there is a presence of oxygen near us. So we can easily catch fire, right? But for example, somebody came, once I got once the fire, like I got fire, then what will happen? Somebody came and they just wrapped me with the blanket. So what they will do? They will stop the flow of air, right? And right now I am not surrounded with air. I am surrounded with the blanket. So what will they
Okay.
are stopping the oxygen from reaching the body, right? So once they stop, so what will happen? Of course, a time will come that there will be no fire at all. Why? Because we stopped the oxygen from reaching the body. So see, for example, the man man catches fire, right? And nobody is doing nothing. So what is happening because air is everywhere. So because of air, heat is being, you can say fire is being increase, right? So now what we have to do, we have only one solution, that we need to cut the supply of oxygen. And how we can cut that? If we will wrap that entire body with a blanket or something like that, so we will automatically stop, or we will automatically cut off the contact of oxygen and the body. And when there will be no oxygen, then there will be no fire. So that's why we wrap the person with the help of blanket, or not blanket, maybe any product which you can say which can stop the flow of this air, or they can stop the contact between air and the body. I hope I have
Okay.
made myself clear, right?
Yes, ma'am.
Yes. So you have to remember the concept of oxygen only, right? So what is the concept of oxygen, ma'am? When there is sufficient oxygen, the high flame. When there is insufficient oxygen, you can say flickering of the flame. When there is no oxygen, no flame. Simple, right? Okay. Next, does a matchstick burn by itself? How does it burn? So can you please tell me? Matchstick.
Um, Ma'am, when like the
Hmm? You rub that, right? For example, you have matchstick, right? You are going to, with the help of matchbox, you are going to rub it. Yes.
yes,
Right. So when you're going to rub it, then there is oxygen. You already know that oxygen is present everywhere, right? So with the help of that material, that the matchbox, plus when you are going to rubbing it, right, with the in the presence of oxygen, then only it will catch fire. So somewhere you, for example, you are trying to produce this fire, maybe in moon, or maybe in that planet where there is no oxygen. So no matter how hard you try to rub that, you won't be able to produce heat. You won't be able to burn that matchstick. Why? Because there is no oxygen. But in normal days, or in a normal, like in earth, air is present everywhere. So no matter like whether you are in Dubai, whether you are in Saudi, whether you are in India, everywhere you can burn the matchstick, right? Because air is present everywhere. But when you go to other planet where there is no air, so sorry, you won't be do that.
Now
Okay?
forget about burning it. My guy wouldn't. My guy can't live.
Why? Because you are afraid of it. Like you are afraid of fire.
No, mom. I'm saying that forget about burning. He can't live. He or she can't live.
Yes. Yeah, like it's like not even a second. Not even a second. Like yeah, we can survive for I think 3, 4, 5 seconds. Not more than that. Right? Yes. So now, can you burn a piece of wood by lighting a lighted matchstick near it? Why would you have to use a paper or a kerosene oil to start fire in the wood or coal? Have you heard of a forest fire? So you have seen forest fire?
No.
No. So forest fire,
Mom,
what
on TV I've
basically?
seen when in Australia it happened 2 or 3 years ago.
Okay, yeah. So basically, what happens usually, like fire, in a forest, what happens? The trees are basically closely spaced, right? They are not so far away. A forest is basically like there will be lot many trees, right? And those trees, they are like they don't have much space in between. So sometimes what happens, for example, wind is blowing, right? So when wind is blowing, so of course the trees are going to touch each other, right? So they are going to rub each other. So they are going to produce energy, and plus there is a presence of oxygen, so they automatically catch fire. That's the
Oh,
thing. And this is the one reason why it's a natural thing. But sometimes what happen in forest, basically, for example, I just burned the garbage, like a small area. And sometimes because the forest is all linked from one, for example, I just burned the garbage near a tree, right? Sometimes the tree caught fire, and as already told you that trees are closely spaced. They are not far away. Right. So from one tree, it goes to other tree, then other, and somehow it gets the entire forest catch fire. So that's how forest fire. So there are two reasons. One is basically the human made, and the other one is natural fire. Right?
yes, mom. Mom, but if someone actually gets caught doing this, he's
Hmm.
over.
Yeah, you can say it's basically, see, human being, they have lot many options to escape or something like that, because fire is not like that it's going to come so fast. Of course it will take time. So if you are saying that okay, over there trees are catching fire, so you can escape, right? But for example, I'm living over here, I'm
No,
animal.
I'm telling, but if someone gets caught doing this,
This is the, you
uh,
can say, yeah, it's like I would say
goodbye.
nobody should, because yeah, there is no option na, in between you
Well,
are saying, and you people are, yeah. But especially for animals,
welcome to
it's
heaven.
like the direct ticket to heaven, you could say, right? And see, for human beings, you have some alternative option, like you can do things, like you can call fire brigade or something like that. But for animals, it's very tough. Why it's tough? Because you don't have, because animals cannot call fire brigade, right? They cannot ask for help. They cannot bring water, or they don't have any options. So in this, like whenever fire, if the fire takes place, or this forest fire especially, see, forest is being damaged, that's one thing. But on other hand, the animal, and some cause like the people who are living nearby, they also have to leave their spaces, because you cannot stop the fire. For example, you saw one tree, you can stop that, but the entire jungle or the entire forest, I don't think it's possible to control it, right? Because that's the fire. You can say, I hope in 8th class or in 7th class you have a chapter now, fire, friend and foe. Is it in your English
No,
book?
ma'am. In my English book,
Yeah.
ma'am, like in SR or LR.
I don't remember.
Because
You have NCRTs
ma'am,
over here?
ma'am, in here I have NCRTs, but in my previous
Hmm.
school in seventh,
Hmm.
I had a
Yeah,
notebook,
that's why. Yeah.
and in
Yeah.
first
Okay.
term I
Okay.
had SR and LR.
Yeah.
In
Yeah.
my
Yeah. That's why. That's
first
why.
term I was
Yeah.
in
In
Southeast.
NCRT. Yeah. In NCRT, you can say in NCRT 7th class, you didn't have like this. You have this chapter, fire, friend, and foe. See, fire is very much important. Na? You cannot do anything without fire. right? But still, in the same hand, it is also your enemy, the worst enemy, you can say. Okay, fire, it's that like see, in I think in 11th class you'll have a poem in your English literature as well, where it's like people are discussing the things like whether this end this entire world will be ending with the because of water or because of fire. Because see, water, yeah, they can, like this entire world can end, right? And similarly, if you just think about the fire, there are also like there are high chances that it will be getting, like the world can end. So people are discussing the things that whether it's going to end with the help of this or with the help of this. So what do you think? Like which one is better, or which one you think that it will be, the world will be ending over there?
Ma'am, I
Yes.
think something will crash with the earth and ma'am, but
Okay.
if I have
So
to choose, I have to die
huh,
from water or fire.
hmm,
Definitely water, because in fire,
it's like a slow process. Your entire body is being burnt. So I don't know that pain
that
is
is,
like, you cannot compare it,
ma'am,
right?
I'm fine running out of oxygen, but I'm not fine burning.
Yeah, it's like I also feel like that burning is something, burning is a process that, okay, in water, it's like you're not getting oxygen, and within 3 seconds or 5 seconds, you are like done, right? Ticket to heaven. But in fire, you can see your skin is burning, you are suffering that pain, right? And there are high chances, even, even after suffering for 1 hour, there are high chances that you are still alive, right? So, and
Yes,
that
ma'am.
because I've seen the
Yes,
cases. So, see, you can imagine the pain, and still, if you are not dead, that also the pain is something, So, I would also choose
like
water.
when you know you're going to die, when you know
Yeah,
you're going to die, you want to die fast.
yes. So, I would also choose this water. But that okay, I'm happy with water. So, Swar, do you know, do you know swimming? Like, how to swim?
Um, yes, ma'am, but I really don't have anything yet to swim. So
Okay, so you went for
I have,
swimming classes,
I haven't swum for like 2 years. So I
or
don't.
okay? So I think it's swimming is some, because I don't know how to swim. So I think swimming is something na, that once you are aware of it, like you know how to
No,
swim. So it's not
I'm
like
not
that you're
telling
not
that.
practicing.
I'm not telling that I'm jumping into the water and dying. But if something tsunami comes and that
Uh,
the water is
you are
incredibly fast,
ready. You can survive, right?
ma'am, very tough to survive in a tsunami.
I'm like I don't know. Like even I'm I never I went to river and all that, but I no, don't know how to swim. So I'm very new. But this is very, I think people used to tell me that swimming should be like your part of your daily activity, not daily activity, but you should be aware of swimming. It's very important. You don't know whether what the situation can come. Like it can come anytime, right? Floods can come. Even in floods, also we need to swim, right? So yes, there should be, like, if you know swimming, then I think it's a good point for your life, because we are like okay, done with the good things. Okay, so from fire we went to swimming, we went to the world end and everything, right? See, over here you can see one more thing is written over here. See, during extreme heat of summer, at some places dry grass catches fire. So as I already told you, so dry grass they rub each other and they catches fire, right? And it spread to trees, and very soon the whole fire is on fire. So basically, this is natural. Nobody came here, right? And it is very difficult to control such fire, right? Because nobody knows. For example, we people are sleeping, and overnight you can say we got the news that okay, you can see the Amazon fire was there, right? Recently, I guess 1 year back. Amazon trees,
Ma'am,
Amazon junk, I think something related to Amazon. It
The
was.
forest fire in Australia, I know about it, like 2 or 3
Yeah,
years
yeah,
back.
yeah. Yes, 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 yes. So that was the Amazon forest, no? If I'm not wrong. Maybe I'm
Ma'am,
not
I
that
don't know.
much aware. I'm not that much good in geography, but still, like I'm not aware of exact places over the world, but still, that's just okay. So next, do these experiences tell you the different substances catch fire at different temperatures? So you already know that it's not compulsory that if fire is like the matchstick is catching fire at this temperature, so trees will be catching the catching fire at the same temperature. No, it's nothing like that. Okay, just a minute. Okay. Now, the lowest temperature at which the substance catch fire is called ignition temperature. So, ignition temperature is basically the temperature at which you will catch fire. But there are two temperatures. One is the highest one and one is the lowest one. So, the lowest temperature at which your substance can catch fire, that is your ignition temperature. Okay, clear? So, we have a history of matchstick over here. So, let's just study that. I think it's interesting. So the history of matchstick is very old. More than 5,000 years ago, small pieces of pine wood dipped in sulfur were used as matches in ancient Egypt. Right. So if I'll ask you from where this concept of matchstick came, so it came from Egypt. Right. So what happened basically, you can see the pine wood. Right. So pine wood was there. They were dipped in, the sulfur. Right. And that whatever product was made, it was being used for that. Right. So the modern safety match was developed only about 200 years ago. So the modern, earlier they were using directly the pine wood dipped in sulfur, right? But now from recently 200 years ago, the concept of matchstick was evolved and people started using matchstick. Okay. Now a mixture of antimony, trisulfide, potassium chlorate and white phosphorus with some glue and starch was applied on the head of the match made of suitable wood, right? So it was made up of wood. You can see the matchsticks are made up of wood, right? So when stuck against the rough surface, white phosphorus got ignited due to the heat of friction. This started the
Ma'am,
combustion of the match. Yeah.
ma'am, but I actually am I'm kind of confused in ignition temperature. Exactly what is it? Sorry,
See,
can you use the
see,
example?
what is temperature? Temperature is normally a temperature, right? So ignition is basically the burning, right? So ignition is basically the lowest temperature, right? At which the substance can catch fire, right? So you can say catch fire or you can say ignition is basically the burning, right? So when you will burn, when you will catch fire, then only you will burn, right? So ignition is, for example, whenever we say, okay, so sorry. Yes. So basically, see, ignition is burning, right? So the lowest temperature at which substance catches fire, that temperature is ignition temperature. So if I ask you what is the temperature, this temperature, ma'am, this is the temperature at which substance catch fire, right? That means that burning takes place. Once you will catch fire, then only the substance will burn, right? So you need a temperature for that, right? Without
Ma'am,
temperature,
ma'am, then can you explain this sentence?
which one?
White phosphorus got ignited due to the heat of friction.
Where it is written?
Ma'am, in the matchstick history only.
Okay. Wait, I'm not
I
getting
mean,
the
it's
line.
the second paragraph, second
Yeah,
line.
white phosphorus got ignited it's not ignition temperature, Swar, it is ignited, right? So
It,
ignition is basically burning. When I'll tell you ignition temperature, so that is the temperature, the lowest temperature at which the substance will catch fire. Ignition means that it already caught fire,
okay.
right? Clear? So ignition is basically a process. Initiation means that it already went through the process of ignition and now it is ignited. We did that. Combustion is a process and combustible, the substance that undergoes combustion. Same way, ignition is a process and similarly ignition due to that. Okay. Now I think I have made myself clear, right? Yes. Now, these days, the head of safety match contains only antimony, trisulfide, and potassium chloride. So nowadays, see, it is evolving. Nowadays, what you are going to use? You are going to use this antimony, trisulfide, and potassium chloride. The rubbing surface has powered glass and little
Where
red
is
phosphorus.
it?
Sorry,
Oh, okay, okay.
the last paragraph. Okay. So basically, you need, like, what the main motive of this story is. They are telling you that earlier it started from the sulfur one, right? The pine wood and all that. Then again they change it. But nowadays, for the safety purpose, they are using this. That's it. Okay, so you have to remember one thing, that the powder substance, right? The you have one is matchbox and one is matchstick, right? So the matchbox, you have the rubbing surface over there, right? It has powdered glass and little red phosphorus, right? Which is much less dangerous. When the match is stuck against the rubbing surface, some red phosphorus get converted into white phosphorus. This immediately reacts with potassium chloride and in matchstick head to produce some the heat of the things. Clear?
Yes, ma'am.
Okay. Now, yeah. We find that the combustion substance cannot catch fire or burn as long as its temperature is lower than the ignition temperature. Remember one thing. If the temperature is lower than the ignition temperature, because ignition temperature itself is the lowest point. If apart from that, if the temperature is lower than the ignition point itself,
It
then there
can't
will be
burn.
no fire. Yes, it will not burn. Right? So have you ever seen cooking oil catching fire when a frying pan is kept for a long or burning stop? So kerosene oil and the wood do not catch fire on their own at room temperature, but still, if kerosene oil is heated a little, it will catch fire. But if wood is heated a little, it would still not catch fire. Does it mean that ignition temperature of kerosene oil is lower than that of a oil? Does it mean that we need to take special care storing kerosene oil? The following activities is essential for substance that reach ignition temperature, the burn. So basically, ignition temperature is burning point. So for example, you are burning the substance for a longer period of time. So of course, what will happen? It will spread, right? For example, if you are burning the substance, of course it will not slow down, it will automatically spread out. So if you, for example, kerosene, you already know kerosene, we discussed it, that if you we cannot keep it in open because it easily catch fires, right? So it is very, you can say, prone to catching fire. So whenever there you are going to keep it in open, so for example, you kept kerosene oil over there and you left it, it is burning somewhere, oxygen is being supplied because oxygen is everywhere, right? So what it will do after a point, it, of course it is burning, but after a point it will spread out, it will do a rapid catch fire. Why? Because oxygen is basically provoking kerosene to catch fire. So it will, somewhere you have seen that, of course you are burning something and the fire will come above that, the frying pan or something like that. Okay.
Yes,
Okay,
ma'am.
now if we continue heating a cup, we can even boil water in the paper cup. See, Sim, can you think of an explanation of this phenomena? See, over here, what happens to the empty cup case? What happens to the paper cup with water? Does water in this cup become hot? See, over here, what they are doing, this is an activity. So, what is our activity? Make two paper cups by folding a sheet of paper. Okay, pour about 50 ml of water in one cup. Okay, and heat both the cups separately with a candle. What do you observe? So, you can say here you have paper cup and here you have water, right? So what happens to the empty paper cup? What happens to the paper cup with water? Does water in this cup become hot? Okay, now the question is this. Okay, now ma'am, what is the question? If we continue heating the cup, we can even boil water in the paper cup. So you can see paper is something, it can easily catch fire, right? But now if you will continue, so of course, see, if you are going to burn this one, so it will catch fire and it will be converted into ashes, right? But for water one, if you will continue keeping it, you can even boil the water. So ma'am, how can it be possible in paper cup you are going to boil the water? It's something, suspicious or something interesting, right? So yeah, so can you think of
Yes.
the explanation of this phenomena? See, the heat supplied to paper cup is transferred to water by conduction, right? So heat is supplied to paper cup is, see, whatever heat is being supplied to paper cup, what they are doing, they are, transferring it to the water, so that paper cup is not taking the heat, right? It is transferring it. So for example, somebody gave you a heat, you are not taking that heat. So because if you are paper, so if you will take that heat, you will burn, right? But if you will transfer that heat, though you are a paper, but still you won't burning because you are not using that heat, right? So if you are going to transfer that thing, so in the presence of water, the ignition temperature of paper is not reached. Remember one thing, you have to reach ignition temperature or above ignition temperature in order to burn, right? So you need that temperature. So if in a paper cone you are keeping water, so water is what water is doing, water is doing the cooling effect somewhere, right? So when water is there, that you cannot reach to the ignition temperature, right? So when you are not going to reach ignition temperature, of course there will be no burning, right? So the substance which have very low ignition temperature and can easily catch fire with a flame are called inflammable substance. So you already, so see, this was still here. It doesn't mean you got the explanation that you took two cup. One was simple paper cup and other was your paper cup with your water, right? So now the water cup didn't catch fire, but the simple paper cup catch fire. So why? Because of course heat was he that paper cup absorbed heat. But coming to the water part, what water the heat the paper didn't catch fire. Why? Because it transferred the object to the other one, right? Transferred the heat to the water and it boiled. Now we are done with this. Now the last part is the substance which have very low ignition temperature and can easily catch fire with a flame are called inflammable substance. Okay, example of inflammable substance are petrol, alcohol, LPG. Clear?
Okay, ma'am.
So what are inflammable substance? Inflammable substance are those substance which can easily catch fire and they have very low ignition temperature. Clear? Okay.
Yes, ma'am.
So I think I have made the combustion part very much clear to you, right?
Yes, ma'am.
Now you are aware of the chapter, like this chapter combustion and fuel. My main motive was to teach you the combustion today. Why? Because your chapter is combustion and flame. So